Hi, welcome back. We're just setting up our experiment. You just caught us setting up our experiment.
Yeah,
so what do we have here, Sam?
Yeah, so today we're going to be talking about capillary action. Capillary action is this really cool feature of water molecules and how they interact in the world, and they allow a lot of sort of simple things to happen. And we're going to do that through an experiment called walking water. So, guys, I think it will start just like this. Nate, could I have you fill all three of these glasses up just about halfway for me with this water?
What are we doing?
Can you fill these three glasses?
All right, how far?
About halfway.
Okay.
Sometimes you have to repeat things more than once.
Like a student today.
For students.
Yeah.
That's exactly right. I've gotten
Different
used to
learning
saying
styles.
things 5 or
Different
6
learning
times.
styles.
I was really focused on my OCD setting up these
Nate was
food
just
coloring.
modeling how my students treat me.
Yeah.
Okay.
All right.
And now I'll let each of you fine young people pick your own special color. So whichever color you want, choose one.
Green.
I get blue.
I'll do red.
That's actually yellow.
That one's
You want
yellow.
red?
Oh,
You
it
can
is
have red
red.
if you want.
Oh, yeah.
I know the liquid looks red, right?
It
But
does.
the
Yeah,
cap
interesting.
color is sort of our
Okay.
indicator. Okay. So we'll just start by, we're going to add food coloring in because it helps us to visualize what the water's doing, and also because food coloring looks cool. So each of you gets your cup, and go ahead and put about 3 drops of your food coloring into your cup.
3 drops.
You just want to go ahead and give Jeff one there. And
Yeah, I guess so.
That one on that.
You can have a cup.
let's be nice,
Thanks.
Nate.
Yeah.
Let's
3
be
drops.
nice.
Can I do more?
Let's try to stick with 3,
I always
Becca.
like to go overboard with the color.
And then Becca, would you hand me just on that tissue box behind you or 2 paper towels? Oh, you're the best. Okay, great. So I just wanted to start with a really basic version of what this is. So the idea behind capillary action is this. Water molecules have a positive end and a negative end. If we could actually just jump to my computer screen really fast to take a look at what that looks like. Most of us probably know that water, the chemical formula for water is H2O, meaning 2 hydrogens and 1 oxygen. You can see in this image, 2 hydrogens, they sort of look like the ears on like a Mickey Mouse face, where the O, the oxygen, would be sort of like Mickey Mouse's face. The hydrogen ears are the positive end of this molecule, and the oxygen face, or chin, I guess in this case, is the negative end. And what's really cool, this allows water to do so many cool things, but one of the biggest is capillary action and the ability of water to stick to itself. So you can imagine since water has 1 negative end and 1 positive end, water molecules tend to hook together like little magnets. Okay, so Nate and Becca, I'm going to have you guys do this one. Nate and Becca, do you see I have drawn a green line on the bottom of these paper towels? Mm-hmm. Okay,
see.
This is what I want you to do. I want you to stick your paper towel into your colored water as far as the green line and no further. Is that clear?
Got it.
Yes.
Okay. So I was wondering if I had to repeat it for Nate.
All right.
Sometimes you do.
Not this time.
To the green line, Becca, but no further.
But do I stick it in
No,
there?
stick
or-
it down to the green
Tried.
line. Okay, now
But
you
it did
pull it
it
out, Becca.
itself.
Now pull it out, Becca, and pull it out, Nate.
Oh, pull it out.
And what do we have? Did the water stop at the green line?
It did not. I
No,
actually
I
tried to
panicked
follow
a little.
your directions.
Yeah, you
and
can
it
see.
went too far.
I said, oh
both
no.
of these perfectionists were probably, oh my God, it went past the line.
Oh, no.
Why is it, you guys, why is it that the water passed the line? You didn't dip it as deep as that. Why did the water go further up?
Just absorbed in the paper towel.
So yeah, we often use this word absorbed, right? And the reason that it absorbed is this. The magnetic interaction, the magnetic attraction between the water molecules and the paper towel is actually slightly greater than the magnetic interaction between the water molecules themselves. So as one water molecule gets pulled upward against gravity, it should be noted, onto the paper towel, all of its other water molecule buddies can join along because they're magnetically attracted to that guy who got pulled up.
So because of magnetic force, that's what happened?
It's what we call electromagnetism.
Electromagnetism,
So in science, electricity and magnetism sort of get stuck together. Technically, they're the same thing. We just see them in different ways. Little water molecules are electrical, and they form this magnetic field. Negative on the oxygen end, positive on the hydrogen end. But in general, did you guys see how quickly that water climbed up the paper towel?
Yeah, I did.
Okay, cool. So what we do in this experiment, it's something called walking water. I'm going to use your guys' cups, but can we move them off to the side for just a second?
All right.
Awesome. Okay, so let me give you guys an example of the walking water experiment. So we'll put that like that, see if we can get, I'm not sure if that's the right way to put it for the shot, but in any case, Jeff, what color do you see in the leftmost cup? And Jeff, in the cup that's closest to you, what color is the water?
The color is red.
Indeed. And Nate, the cup closest to me is?
Yellow.
Gotcha. And then Becca, the color in the middle is?
Orange.
Yeah, and you get orange when you mix yellow and red, right? Mm-hmm. So it sort of looks like we just filled up these 3 cups and dyed one red, the outside one yellow, and the middle one orange. But in fact, what we actually had was dyed water climbing through the paper towels into that center cup, and then the 2 colors of water, yellow and red, mixed to create orange water. Here's another example from a little bit earlier. Nate, you want to move that one for me?
Move it back a bit.
You're the best. Okay, so here's another one where we had blue and red water that was supposed to create, what should blue and red create when they're mixed?
Purple.
Purple.
You can see that the purple we got actually is it's a bluish purple.
Just the bluest,
It's
stronger.
not a super clear one. Now, the first example we showed you was started at 10:30 this morning, so it's been going for, what is that, like about 7 hours. This guy, the one we're just looking at right now, has been going since about 1 o'clock today, so just about 4 hours. And then here's one I started just as the show was getting going. Nick, can you pull that one back for me?
Yep.
And you can just barely see that the yellow water on the left and the blue water on the right is mixing to form what color at the bottom of that center one?
Green.
Green. Pretty cool, right? I like green because it's such a stark, obvious difference.
And so you just started this at the beginning of the show?
I literally started at the beginning of the
already
show.
doing that much.
And what I'm going to show you guys now is how you would set this up at home. And it is, in some ways, it's a little bit slow, but it also happens quickly enough that we can see some of it happen. All right, so let me pull this guy over here. And can you guys set all of your cups up there? All right. We're going to set up kind of a long one here. So can we put 2 empty cups between your guys' filled cups?
Sure.
Okay. And then you can actually, I'll take this from you.
Okay.
Sorry, I didn't mean to, Becca, also take your, sorry to make you guys hold
the
soggy rags there.
So we're going to angle it a bit so we can see it on camera a little bit better.
Perfect.
Let's move the tray out of the way.
Oh, excellent. Thank you.
Maybe, or put it behind.
a little bit better.
You got everything in there?
Oh,
Wait,
Is that
you're
the wrong
out.
way? Okay.
There we go.
lovely. Okay.
All right.
So what we're going to use as the connector is paper towel. I've just taken some really simple paper towel, ripped it into a small sheet, and then folded it into a thin strip like so, as you can see. Okay, and what we're going to do is we're going to use this strip to bridge from the dyed water into the empty water. And I'll have us do it one at a time because we can really watch the capillary action of the water molecules climbing up the paper towel. So Nate, go ahead and stick one end into your green water.
All right.
And then you can fold the other dry end down into the empty cup. Fantastic.
Wow, that's actually going pretty quick.
Yeah, and you can actually see how fast that green water is traveling up through the paper towel. And again, the food coloring is really there so that we can just see this happening visually, but obviously if this was just plain water, it would be happening in the same kind of a way. And that's why paper towels are so great for cleaning things up, is they have this absorptive function, right? Water is really attracted to the fibers in the cloth, and so that's why so much of it gets picked up when we use it to clean up our messes. All right, Becca, are you blue?
I'm blue.
Oh, well, you're special, so you get to do two. Okay, so one going into the green cup there.
All right. Oh wait. Green
So
cup?
from the
Green
blue,
cup?
excuse me, from the blue
That's
into
what
the empty cup between the
That's
blue
what
and
I
the green.
thought.
Excuse me. Yeah, and again, this first part really does happen quickly, and you can see Nate's has already really bridged the top.
Yeah,
here.
it's already coming back down.
It's just starting to come back down.
Oh, mine's already coming back down too.
Yeah.
It helps if you actually fold it before you. It's a little easier that way.
And then Becca, you can also do one from your blue into the empty cup
I get
between the red and the blue. Yep, you're very special.
There we go.
Look how quickly that goes. Amazing, isn't it? Individual water molecules. And right before I let Jeff do this, Becca, would you click the tab just next to that? If we could jump to my screen one last time. This is just a really simple diagram that shows sort of how capillary action works on a step-by-step basis. So we can imagine that tube sort of represents anything that has that magnetic attraction to water molecules. So paper towels do it, really thin glass tubes do it, and actually this is how roots of plants soak up water. So lots of us think, oh yeah, roots, they suck up the water that they need. No, There's no sucking action in roots. Roots just sit in the water, and natural capillary action allows, again, a magnetic effect between water molecule and root. So one water molecule jumps to the root. Now all the other water molecule buddies can just join right along with the first water molecule, and they can sort of piggyback over each other, leapfrog, I guess I would say, over each other to climb up the piece. All right, Jeff, last but not least.
All right.
So from the red into the blue there,
All right.
and I guess if we mix the red and the blue, we should get purple. If we mix the blue and the green, we should get, what is that, like brown or something? What's blue and green?
Blue and green.
Something horrible.
Blue and
makes
green
bluish
is
green.
just bluish
Oh,
green.
bluish green.
It's just, yeah,
Oh,
I was going
teal.
to say it's green, but a little bit more.
Maybe we'll
teal.
get a little aquamarine. But this is one of those things where there's sort of a long-term payoff here. So what we will do, so for the rest of the show here is, I'll keep it just sort of on the edge of my desk. And as we go through the rest of the show, we'll continue to answer some science and math questions. And right before the end of the show, we'll try to remember just to look over and see how far has this gone.
Cool.
Cool.
Kind of neat, right?
Yeah.
Yeah.
You guys have any follow-up questions here at the end?
So the water makes its way all the way down, and then does it actually fill up?
Yeah, it actually does. So there's a point at which, that's actually a great question. So there's a point at which the water becomes, the paper towel becomes saturated with water. And as other water molecules start to continue to climb from that original cup, they'll effectively be pushing other water molecules at the front out into the empty cup.
Okay.
So we'll get a mixture of the two colors of water. And we should eventually get even levels between all the cups.
Oh, they'll all be-
all cups
okay.
should even out to the same level. That won't happen in the time that we have here left in the show today, but it would probably happen over the course of the next 4 to 5 hours.
Cool.
Do you know what the difference is between like the cheaper paper towels and the like bounty, thicker, quicker, picker-upper?
Well,
paper
so
towels?
typically, and I don't actually know that much about paper towel like science, but my understanding is that typically better paper towels have more ply, so individual
More,
thin
okay.
layers of fibers. So and they're better put together, and so it's really just a question of there's more of that fibrous material for the water molecules to attract onto.
That makes
the
sense.
thinner and less fibers there are, just ultimately the less magnetic action there is, the less water that it can hold. Does that make sense?
Yeah.
That does make sense.
Fantastic.
That'd be a good experiment to do at home.
And actually, yeah, that's something else that we could do, right? We could test this, or you at home could test this experiment with different qualities of paper towels. So, anyways, thank you guys so much for joining us here in the Science Lab again. We're going to head back to the Homework Hotline studio. We'll see you back there in just a minute.